Hi everyone, welcome back. When workloads run inside a VPC, they often need to talk to AWS services like DynamoDB. But here's the twist. DynamoDB isn't inside a VPC, it's a regional public service. So does traffic go over the internet? And if not, how does it stay private? In this video, we will use AWS Lambda as an example of a VPC resource, and we'll see how it can access DynamoDB privately using a Gateway VPC endpoint without NAT or internet access. Even though we are using Lambda for this demo, the same principle applies to other VPC resources like EC2 instances or ECS task. Alright, now let's visualize what's happening behind the scene. In this diagram, we can see we are in a region called US East 1, where we have a VPC called Demo VPC. Inside that VPC, we are in an availability zone called US East 1A. And inside that availability zone, we are creating a private subnet. On the right, we can see we have Lambda service and Amazon DynamoDB. Please note that these two services are outside of the VPC but inside of the region. Now let's move to this AWS Lambda service. We are using VPC-Enabled Lambda service, so we will be creating an ENI in the private subnet. Here in Lambda function, we also need to create a security group called Lambda DynamoDB SG, where the SG outbound rule will use HTTPS traffic to DynamoDB prefix list. We will also be creating an IAM role with the following permissions: Amazon DynamoDB full access for the demo purpose, and AWS Lambda basic execution role, and finally AWS Lambda VPC access execution role. Now moving to the private subnet, we have this ENI that will be created for us as we are using VPC enabled Lambda. From this arrow, you can see that in the private subnets route table will help us to direct our traffic to the gateway endpoint, which will eventually reach Amazon DynamoDB. That will be it for this diagram. Let's move to the hands-on. Now that we are in the AWS console, let's create a DynamoDB table. Let's click DynamoDB. Let's click create table. Give this table a name. For partition key, let's use ID. Let's scroll down and click create table. Let's wait till the table gets created. Right now the status is creating. Now that our demo table is finally created, let's select this demo table. From this action drop down, let's click create item. Let's give this item a value. Let's click create item. Now we can see we have successfully created an item in the demo table. Now let's move back to our console and let's open VPC. Let's click create VPC. Let's give this VPC a name called demo. Scrolling down, for number of availability zone, let's select 1. For number of public subnet, let's select 0. For number of private subnet, select 1. Scrolling down, for VPC endpoints, select none. Now let's click create VPC. Our VPC is finally created, so let's click view VPC. Under resource map, we can see we have created a VPC called demo VPC with one subnet in US East 1A called demo subnet private 1 US East 1A, and we can see it has also created a route table called demo RTV private 1 US East 1A. Now let's create gateway endpoint for our DynamoDB. From the left hand side under private link and lattice, let's select endpoints. Click create endpoint. Let's give this endpoint a name. Let's scroll down and under services, let's select type of type equal to gateway and select a service name with .dynamodb of type gateway. Scrolling down for the VPC, let's select our demo VPC. Scrolling down, we want to associate demo RTB private 1 US East 1A route table. So let's select it. Scroll down and let's click create endpoint. We can see we have successfully created our VPC endpoint. Now let's go back to our VPC console and under the route table for our private subnet, let's look at it. You can see we have two routes, one for local and another for our VPC endpoint that we created recently. For any address range in this CIDR range, the target would be local, and for any other prefix list for our DynamoDB, the target would be our VPC endpoint that we created. So now let's create a security group for our Lambda function. Let's click create security group. Let's give this security group a name. For description, let's put dot. For VPC, let's select our demo VPC. For our outbound rule, let's delete this and click add rule. For the type, let's select HTTPS. For this destination, let's select prefix list called .dynamodb pl02cd2c6b. Let's scroll down and click create security group. We can see our security group called Lambda DynamoDB demo was created successfully with proper outbound rules. Now let's open IAM. From the left hand side under access management, let's click roles. Let's click create role. For the use case, let's select Lambda as we were creating this role for Lambda. Scroll down and let's click next, and let's add our 3 role that we needed. Let's look back to this diagram. We see that we need to have 3 permissions for this role, so let's add them. For the demo purpose, let's select Amazon DynamoDB full access. For second permission, let's select AWS Lambda basic execution role. Now let's add our last role, which is called AWS Lambda VPC access execution role. Now we can see under permission policies, we have successfully selected 3 of our needed permissions for our role. Let's click next. Here we can see our selected role. Now let's click create role. Okay, first let's give this role a name. Once we have given this role a name, let's click create role. Let's wait till the role is created. We can see a message called role Lambda DynamoDB role created. Now let's create a Lambda function. Now let's click create function. Let's give this function a name. For runtime, let's choose Node.js. Under change default execution role, let's select use an existing role. Let's select the drop down and let's select our newly created role for our Lambda called Lambda DynamoDB role. Let's click additional configuration. Click enable under VPC and select a VPC called demo VPC. Under subnets, let's select our private subnet. For this security group, let's select security group called Lambda DynamoDB demo. Scrolling down, let's click create function. Let's wait till our function gets created. Alright, we can see that we have successfully created our function called private DynamoDB demo. Scrolling down under the code tab, let's click upload from and select .zip file. Let's click upload and select lambda demo.zip file. Click save. Now you can see we have a new Lambda code. This Lambda function connects to DynamoDB and fetches the item from the table called DynamoDB with ID of 1. If it succeeds, it returns the item. If there's an error, it will return a 500 with an error message. Before executing this function, let's move back to our DynamoDB. In DynamoDB, let's select our item and edit it by clicking edit item. So let's give this ID of 1, click add new attribute, select string. For attribute name, let's give it a name, and for value, let's give it a value called hello from private DynamoDB. Let's select this tick box and click recreate item. Scrolling down, we can see we have successfully created an item with ID of 1 and with message of hello from private DynamoDB. Now let's move back to our Lambda function. and see if our newly created item with key ID of 1 gets returned back from our DynamoDB. Let's click deploy. Now let's move to the test tab. Let's click test. We can see we have successfully executed our function. Now let's look into the details. Under details, indeed, we see we have a message called hello from private DynamoDB with ID of 1 that we got back from our DynamoDB. To recap, we saw how a Lambda function in a private subnet can access DynamoDB without ever touching the internet. The Lambda attaches an ENI in the subnet. The subnet's route table sends traffic to the Gateway's VPC endpoint, and DynamoDB responds over AWS private network. This same principle works for any VPC resources, EC2, ECS task, or containers whenever you want private access to AWS services. If this video helped you understand private connectivity in AWS, don't forget to like and subscribe for more hands-on AWS tutorials. Thanks for watching, and I will see you in the next video.